children, have you revised yesterday's topic of polymers? Okay, today we are going to start completely a new topic of organic chemistry, that is haloalkanes and haloarenes. I know you are interested to learn organic chemistry, so first let us start with the chapter haloalkanes and haloarenes. As you know, the total weightage of organic chemistry is 18 marks. Out of this chapter carry 4 marks. Okay, so let us start with the chapter haloalkanes and haloarenes. First, let us say what are halogen derivatives. Halogen derivatives. Do you remember what are hydrocarbons which you have studied last year? Yes, hydrocarbons are compounds of carbon with hydrogen, and halogen derivatives are derivatives of hydrocarbon. That is, you know, the general formula of hydrocarbon is generally CnH2n plus 2. This is saturated hydrocarbon. From this hydrocarbon, you remove one or more hydrogen atom and introduce halogen atom, that results in the formation of halogen derivatives. So, halogen derivatives are derivatives of hydrocarbon obtained by substituting one or more hydrogen atom by halogen atom. So, generally we can say that halogen derivatives possesses the general formula CnH2n plus 1 X, where X stands for halogen. Is it clear? Halogen derivatives are derivatives of hydrocarbon which are obtained by substituting one or more hydrogen atom by halogen atom. These halogen derivatives are of different types. So first let us study about type of halogen derivatives, a classification of halogen derivatives. Halogen derivatives can be classified on different bases. First, let us classify on the basis of hybridization. So, first type of classification we are going to study on the basis of hybridization. On the basis of hybridization, and you know that carbon undergoes all the three types of hybridization, that is sp3, sp2 as well as sp. So, first let us study the classification of the types of halogen derivatives on the basis of hybridization. First, let us see the halogen derivatives which possesses sp3 hybridized carbon. On the basis of the presence of sp3 hybridized carbon, halogen derivatives can be classified into three types. First example you consider CH3, CH2, X. In this case you can see that the halogen is directly attached to sp3 hybridized carbon. This type of halogen derivative where halogen atom is directly attached to sp3 hybridized carbon is termed as haloalkane or alkyl halide. It is called haloalkane or alkyl halide. Is it clear? The type of halogen derivative where halogen atom is directly attached to sp3 hybridized carbon is termed as haloalkane. Second example you consider CH2 double bond CH single bond CH2X. Listen here. In this case, halogen is again attached to sp3 hybridized carbon, but it is adjacent to a double bonded carbon. Halogen atom is directly attached to sp3 which is adjacent to an sp2 hybridized carbon. This type of halogen derivative is termed as alkyl halide. It is called alkyl halide. And the third type we can consider another example. Again you see, here the halogen is attached to sp3 hybridized carbon which is adjacent to a benzene ring. This type of halogen derivative is termed as benzyl halide. Is it clear? So, on the basis of sp3 hybridized carbon, we classify halogen derivatives into three types. If halogen atom is directly attached to sp3, then it is called haloalkane. If it is attached to sp3 adjacent to a double bonded carbon, it is called allyl halide, and if it is attached to sp3 adjacent to a benzene ring, it is termed as benzyl halide. Okay, that is about on the basis of sp3 hybridized carbon. Now let us consider if halogen atom is attached to sp2 hybridized carbon. On this basis, we can divide the halogen derivatives into two types. Suppose CH2 double bond CHCX. In this case, you can see that halogen atom is directly attached to sp2 hybridized carbon. This type of halogen derivative where halogen atom is directly attached to sp2 hybridized carbon is termed as vinyl halide. It is called vinyl halide. If halogen atom is directly attached to sp2 hybridized carbon, it is termed as vinyl halide. Now, second case you consider, if halogen atom is directly attached to sp2 hybridized carbon of a benzene ring, then it is termed as aryl halide, or they are called haloarenes. Is it clear? So, on the basis of sp2 hybridized carbon, we again classify the halogen derivatives into two types. If halogen atom is directly attached to sp2 hybridized carbon, that is double bonded carbon, then it is termed as vinyl halide, or if it is attached to benzene ring directly, then it is termed as aryl halide or haloarenes. Is it clear, children? That is about the classification of halogen derivatives on the basis of hybridization. Second type of classification we can consider on the basis of number of halogen atoms. On the basis of number of halogen atoms present. On the basis of number of halogen atoms present, halogen derivatives can be classified into three. That is monohalogen derivative, dihalogen derivative and polyhalogen derivative. That is, again you consider, suppose if it is CH3, CH2X. Here we can see that one hydrogen atom is replaced by one halogen atom. This type of halogen derivative is termed as monohalogen derivative. Okay, you can see the presence of only one halogen atom. On the other hand, if you consider CH2Cl2 or CH2X2. In this case, two hydrogen atom is replaced by two halogen atom, then it is termed as dihalogen derivative. That is, halogen derivative which consists of two halogen atom is termed as dihalogen derivative. On the other hand, if it contains more than two halogen atom, then it is termed as polyhalogen derivative. Is it clear? So, on the basis of number of halogen atoms present, we can classify halogen derivatives into three types: monohalogen derivative, dihalogen derivative and polyhalogen derivative. That is simple example chloromethane. We can consider it as an example for monohalogen derivatives. Methylene chloride, dichloromethane is an example for dihalogen derivative, or you consider simply chloroform. This is an example for polyhalogen derivative. So, is it clear? That is about the second type of classification on the basis of number of halogen atoms present. Now, let us consider third type of classification of halogen derivatives on the basis of nature of carbon atom. Third type of classification is on the basis of nature of carbon atom. On the basis of nature of carbon atom, again we can divide it into three types, that is primary, secondary and tertiary. Even we can have the fourth type also, that is quaternary, but now we are dealing only with three types. Primary haloalkanes, so primary halogen derivatives means, suppose if halogen atom is attached to a carbon which is attached to one other carbon atom or no other carbon atom. This type of halogen derivative is termed as primary halogen derivative. In this case, it is specifically primary haloalkane. If halogen atom is directly attached to primary carbon, That means the carbon which is attached to one other carbon or no other carbon is termed as primary haloalkane. On the other hand, you consider, in this case, you can see that the second carbon is attached to two other carbon. This type of carbon is called secondary carbon. If halogen is attached to secondary carbon, then it is termed as secondary halogen derivative. Yes, secondary haloalkane. And if the halogen is attached to three other carbon, then it is termed as tertiary haloalkane. Tertiary halogen derivative. Is it clear? If halogen atom is attached to primary carbon, that is the carbon which is attached to one other or no other carbon is termed as primary halogen derivative. If halogen is attached to secondary carbon, that is the carbon which is attached to two other carbon is termed as secondary halogen derivative. And if the halogen is attached to three other carbon, that is the tertiary carbon, then it is termed as tertiary halogen derivative. Is it clear, children? That is about the classification of halogen derivatives on different bases. So today let us wind up this class, and next class we will be explaining about nomenclature of halogen derivatives.